We've done a small recap of population proportion testing when it comes to one population testing. But now let's have a look how we do it with two populations. So the problem of comparing two population proportions means that we have observations from population A that have success probability PA, and then observations from population B that have success probability PB. And the experimenter's goal is to make inferences on the difference between the two population proportions, based upon observed values from sampling. So a good way to do this is calculate two-sided confidence interval for PA minus PB. So such a confidence interval is calculated as, first of all, difference between the two sample proportions, and then, since it's a difference, the two-sided interval needs half of alpha on each side, so we have Z alpha over 2, and then we have the combined standard error. So like in the case of known variances in two-mean testing, these are the known variances for the proportions. And now, since we are not given any theoretical values as those known variances, we actually use the actual proportions here in the variance calculation. If we are to consider one-sided confidence intervals, then of course the values can vary anywhere between -1 and 1, because we can have a case where one population has proportion 0, so the minimal, the other one has maximal, so then we arrive at difference -1, and then the maximal one is 1. And otherwise, it's all the same. When it comes to hypothesis testing, of course, the two-sided case is that null is testing equality of the two proportions versus the alternative that they are not equal. So the two-sided test Z statistic is expressed as follows. We have the difference between the two sample proportions, and then divided by the standard error, where now the standard error is this combined proportion. So we add up successes from both samples, and then we divide by both sample sizes added up. So then the decision here, size alpha hypothesis test, accepts null when we are within acceptance region, so between the critical values on both sides, and then we reject it if we are on either side to the left or to the right from either of the critical values.